In this problem, we want to find the zeros of the polynomial function. So we got x to the fourth minus 6x to the third minus 23x squared plus 192x minus 288 equal to 0. Now, a fundamental theorem of algebra says your largest power tells you how many answers you're going to have, so we're going to have 4 answers. And we're going to put our polynomial on y1, 0 on y2, and use the intersect method to see what we can find. So we're going to come over here, press y equals, clear. And we've got x to the fourth, so I do x caret 4. Press your right arrow key if you're on a T84. It doesn't hurt to do it on any model. Minus 6x to the third. That takes you out of exponent mode. Again, you can do the right arrow key again to get out of exponent mode if you got one of those calculators. Minus 23x squared plus 192x minus 288, and then down arrow to y2, and if you don't already have it there, you press your clear and you put 0. Have to have 0 on y2. So then we'll do second trace, choose intersect, so I'll do 5. And that looks like -6, -7. So let me do inner on first curve, inner on second curve, and I'll put in -6. Trying to find our answers. The answer is where it crosses the x-axis. -5.656854. I know that's not going to change to a fraction, but I can check it to make sure. I do second mode, and then you do math, inner. And doesn't change, so we can't use that answer. So we do second trace, choose intersect. Looks like it touches at a point. Looks like it touches at 3. So let's do inner on first curve, inner on second curve. Now let me put 2 in and show you what happens. If I put 2 in for my guess and press enter. See how it skips that one all together? When it comes and touches at a point, it does weird things. To actually get this answer, you have to input the answer as your guess. As weird as that seems. So do second trace, choose intersect. Inner on first curve, inner on second curve, and I'll put 3 in for the guess. And see how it finds x equals 3. Now I don't know if you noticed or not, but that one it found over here had a bunch of weird decimals. And there was no way that was going to change to a fraction. And how it always works is if you have one that won't change to a fraction, you'll have another one that won't change to a fraction. So this is our only answer. So let's plug that into synthetic division. So whatever number we find, we'll put in the box in the upper left-hand corner. Identify our largest power, which is x to the fourth. So I'm going to have an x to the fourth, I'll have an x to the third, an x squared, an x, and a no x. And write down numbers in front of each one. There's the invisible 1 in front of the x to the fourth. There's a -6 in front of the x to the third. -23 in front of x squared. 192 in front of the x. And then -288. Well, we're going to go through a series of adding, multiplying over and over till we're done. So 1 plus nothing is 1. Always multiply by number in the box, but number you put down there. 3 times 1 is 3. Add. -6 and 3 is -3. Multiply, number in the box, but number we put down there. 3 times -3 is -9. Add, that gives us -32. Drawing a blank. Then multiply, 3 times -32 is -96. Add, that gives us 96. Multiply, and that gives us 288. And then multiply, or add, -288 plus 288 is 0. We get x is equal to 0, which means that x equals 3 is our first answer. Now each answer we find takes it down one more degree. This went from x to the fourth, we're now down to x to the third. Now since this is the only answer we got from our calculator, it probably repeats, especially since it touches at a point. That's usually what that means. So we're going to try 3 again. If we come up with a remainder of 0, then that means x equals 3 is our second answer also. Okay, so I'm going to add, multiply, 3 times 1 is 3. Add, -3 plus 3 is 0. Multiply, 3 times 0 is 0. Add, -32 and 0 is -32. Multiply. 3 times negative 32 is negative 96. Add. 96 minus 96 is 0. Since we found a zero's remainder, that means that x equals 3 is our second answer. Now you might wonder, well, is it our third answer? Let me do it just to show it. If you're writing this down while you're watching this video, you probably don't want to write this part down. But if I plug in 3 again, by the way, this went from x to the third, I'm now down to x squared. But if I tried 3 again, add, multiply, add, multiply, add, and that gives us what, 23? Negative 23. It's not 0, is it? Since this isn't 0, that means that that isn't our third answer. It fails. Which is okay. We found it twice, and we're now down to the x squared level. This is x, and this is our no x, our constant term. So we now have x squared minus 32 equal to 0. Square root property, we want to get the part that's squared by itself, so I take negative 32 to the right side, becomes a positive 32. Square root property says if you have something squared equal to the other side, you drop your squared, and you put a plus or minus square root around the other side. Now 32 is 5 2's. We're going to do the prime factorization. Remember, with square roots, we're looking for pairs of something. Here's a pair of 2's. They're going to come out in front as a single 2. And here's another pair of 2's. They're going to come out in front as a single 2. So we're going to have x is equal to plus or minus 2 times 2. And we're left with a single 2 inside. Or x is equal to plus or minus 4 square root of 2. Now x to the fourth means we're going to have 4 answers. We found 2 here, and plus or minus here, this is your other 2. So we've got all 4 answers.